Hello students, let's go to next topic of our syllabus. If you remember, we have started with thermodynamic processes. We have seen the four processes up till now. Now let's go to fifth one, adiabatic process. So the process in which heat cannot be transferred to the system or cannot be absorbed from the system, that process is said to be adiabatic process. So this adiabatic process is a process in which the walls of the container in which the gas is enclosed is either insulated walls, and so that well insulated walls are used so that internal heat cannot go outside the system to the environment. At the same time, environmental energy or heat can't come inside, so though there is no exchange of heat in this process, and that is said to be adiabatic process. So here adiabatic process, there is a example they have mentioned here, that is if inflamed football or volleyball or tire get punctured quickly, it is seen that the parameter remains constant, but the air from that balloon or we can say ball or tire get leaked to the environment without exchange of temperature. So that is one of the best example they have mentioned here. Apart from this, we know the gas can either be expand or can be compressed. So there is expansion of the gas as well as the compression of the gas. Whenever there is expansion of the gas, it is seen that work done is positive and the internal energy would be negative whenever there is an expansion of the gas. Exactly opposite get occur when the gas get compressed, work done becomes negative and internal energy becomes positive. In this adiabatic processes, there is always change in internal energy. Why it's so? Because there is change in temperature. Whenever there is change in temperature, there must be change in internal energy. So apart from this, yeah, here it is a PV diagram for the same. Yes, the pressure along y-axis and volume along x-axis, and this will be changed from system A to B. It comes like this. It is adiabatic. There is no exchange of heat with the surrounding. There is no exchange of heat with the surrounding or environment, we can say. So the process is adiabatic. Now let's go to thermodynamics of this adiabatic process. Now we know that in thermodynamics of adiabatic process, we know the equation for adiabatic processes. We can write the Boyle's law as PV to the power gamma equal to constant, and that constant is suppose C. This gamma, we know gamma is what? Ratio of specific heat at constant volume to specific heat at ratio of specific heat at constant pressure to constant volume. So this gamma equal to the specific heat at constant pressure to the specific heat at constant volume. Cp by Cv, their ratio is always constant, and that constant is said to be gamma. Sometimes it is said to be adiabatic ratio. Sometimes it is said to be adiabatic ratio. Its value is 5 by 3 for monoatomic gas. It is 5 by 3. Monoatomic gas molecule, we have learned that. And its value is 7 by 5 for diatomic gas molecules, and its value come to be 8 by 6. 8 by 6 is nothing but what? 4 by 3 for polyatomic gas molecules. What exactly monoatomic, diatomic, polyatomic gas molecule, that already we have learned in last chapter. The value of gamma would be this for monoatomic, diatomic, and this is for polyatomic gas molecule, and gamma is nothing but a ratio of specific heat at constant pressure to the specific heat at constant volume. Now let's go for adiabatic system. The thermally isolated system it is. Thermally isolated system from the environment, so the heat can't get exchanged to surrounding as well as heat can't absorb from the surrounding. So this adiabatic change can be result into change in internal energy because temperature is changing. So that change in internal energy and work done, that we have to find out. So you can write here the change in internal energy delta U is a change in internal energy we can represent, and as by definition of specific heat, it becomes Cv into delta T, where Cv is specific heat at constant volume. And what is the work done? Work done when there is change in a volume, Vi initial volume to final volume Vf. Here it is P into dV. That is nothing but a work done. Now as here we know P into dV is a work done. Suppose this is equation 1 as we have written initially, and this is nothing but a PV to the power gamma is constant, that is C. Put the value of P from this equation. P equal to what? C divided by V to the power gamma. Put it here. We can write this equation as equal to integration of Vi to Vf. P is what? C divided by V to the power gamma into dV. As C is a constant, take it outside. So we can write this as C integration of Vi to Vf 1 divided by V to the power gamma into dV. As it is 1 divided by V to the power gamma, We can move it to numerator. We can write the same equation as integration C Vi to Vf. Move this to numerator as it is in denominator v to the power gamma. When shifted to numerator, it becomes v to the power minus gamma. V to the power minus gamma into dv. Remaining things are same. Now there is one equation there is one formula in mathematics. That formula is what? Integration of x to the power n dx is equal to what? X to the power n plus 1 divided by n plus 1. This is the formula for integration. Same thing is there. Instead of x we have the v. Instead of n we have the minus gamma. Use that formula here and rewrite this equation just by putting the value of that formula in this. So we can write one equation as here. Further we can write equal to C integration varies from Vi to Vf, v to the power minus gamma plus 1, v to the power minus gamma plus 1 divided by minus gamma plus 1. In your book they have written this 1 minus gamma. It is same thing. Minus gamma plus 1, or you can write 1 minus gamma. It is same thing. So this is integration, this is C. So that we get here work done. But here as we have just put the values, this should not be integration because we have used the formula. So we should use the bracket where integration varies from Vi to Vf. Now the second part is what? We have to put the upper limit minus lower limit in the formula. Just I will write it here. Upper limit minus lower limit we have to put. So just put here V equal to Vf first, then minus Vi. But this denominator is constant. It doesn't contain the term of V. So take it outside. So we can write this as further work done equal to. So I will write it to this side a little bit. So let's see here. Just I will write here to next part on this part. Next part of this on this side I will write. So we can write here W equal to C divided by minus gamma plus 1 is what? 1 minus gamma. In the bracket we have to put that value. Now what is the value in the bracket? V to the power minus gamma plus 1 is the formula. Minus gamma plus 1 is the formula. As it is minus gamma plus 1, but here we have to put Vf. So it is Vf to the power minus gamma plus 1 minus Vi to the power minus gamma plus 1. So this we have put upper limit minus lower limit. This can be further written as C divided by 1 minus gamma. C divided by 1 minus gamma. In the bracket, just move it to denominator. 1 divided by V to the power F. Power becomes what? V to the base F. Power becomes what? Minus gamma becomes plus gamma. Minus plus 1 becomes minus 1 because it is in denominator. Minus 1 divided by Vi to the power gamma minus 1. I hope you got this because we have just shifted the number from numerator to denominator. So all power gate becomes negative. So whenever there is negative it becomes positive. Whenever there is positive it becomes negative. So we have written it like this. Now further we have to solve it. Before going into further details, as we have written equation 1, PV to the power gamma is C. If you remember this part we have written, I will show it here. PV to the power gamma is C. The value of C is what? PV to the power gamma. Now here it is C. If you move this C inside, what we get? 1 divided by 1 minus gamma. C divided by this. C divided by this. Put the value of C. P into V to the power gamma. So we can write here as P into V to the power gamma is equal to constant, that is equal to C. For we can write Pi Vi to the power gamma equal to Pf Vf to the power gamma equal to constant, that is equal to C. See, I and F are only the final and initial coordinate. Put this value in this, rewrite. So we can write W equal to 1 divided by 1 minus gamma. Inside the bracket, C is what? Here it is F, so put the value of F here. Here it is I, put the value of I there. So just write down here Pf Vf to the power gamma divided by Vf to the power gamma minus 1 minus Pi Vi to the power gamma divided by Vi to the power gamma minus 1. I have put this value in this equation, we get this. Now in this, if we see, it is V up to the power gamma minus 1, V up to the power gamma. If we cancel them, if we cancel this term with this term, what is remaining? Vf only. Similarly, if we cancel this term with this term, what is remaining? Vi only. And further we can write this as 1 divided by 1 minus gamma. In the right bracket, Pf minus Vf, sorry, Pf into Vf minus Pi into Vi, because remaining terms we have cancelled out. So in this fashion, we have find out this as a work done. So we can move it to this parameter to whole divide by this. So either you can write it like that or you can put it as it is, doesn't matter. So according to book we go. So in your book they have shown Pf minus Pf into Vf minus Pi into Vi divided by 1 minus gamma. That is the work done that we have find out here in case of adiabatic process. Now point to remember here in case of adiabatic process, what is the point to remember? When work done is greater than 0, when there is expansion, so we can write here a simple way, expansion. When expansion would be there, okay, you can't see it here, just do it here, I will write it here. Expansion. In expansion of gas would be there, work done would be greater than 0. Expansion of the gas would be there, work done would be greater than 0. Then what we can say? Ti is greater than Tf. Ti is greater than Tf. When there is a compression of the gas would be there, work done would be less than 0, Ti would be less than Tf. So these are the conditions that we are going to impart here on this equation further. Now the point to remember in this equation, just we have written Pf Vf minus Pi Vi. Okay, so we know that Pv equal to what? nRT. So we can use that concept. You can rewrite this equation as further. Pv equal to nR. So it is nR and T is what? Ti minus Tf divided by 1 minus gamma. So this is nothing but by using this equation. This we have written according to the equation of ideal gas. That's it. So this is nothing but what? The theory about which how the adiabatic process get occurred and what are the thermodynamic variables in this that already we have learned. After that you have to remember the part. Remember this article will be there for this isothermal similar to initial process. You have to remember that topic. Now let's go to next part of the syllabus. That is nothing but what? Cyclic process. What exactly the cyclic process is, that we have to learn now. The cyclic process, as its name suggests, that it is in terms of cycle, so that it is said to be cyclic process. So let's start with the cyclic process here. So already I have drawn here a diagram for the cyclic process. So let's start with this cyclic process. So what exactly the cyclic process is? As its name suggests, that is cyclic process. When the system change from A to B, the initial phase is A, final phase is B, and both are at the same place. Same place in the means both are exactly same processes. So when the particles at A, it has some values, some variables. When it comes to the B, it has same values, same variables as that of A. So initial and final processes are exactly same. Either you go by path 1 to B, and again from B to A come by path 2. Still the paths are different. Still here the paths are different in this PV diagram. Still the process is same. So initial and final processes are exactly similar to each other. So that such type of process which can complete, just go like this and again come to original position. In this type of processes, such a processes are said to be cyclic process. They are repeated cyclically. So that are nothing but what? Cyclic process. In this cyclic process, internal energy of system is 0. Internal energy of system is always 0. So you can write Q equal to W. Because U is 0, so Q equal to W for the cyclic processes, which repeated again and again between the two same systems. So return system to its initial state, thermodynamic process that returns a system initial state to its initial state again, that is said to be cyclic process. Now let's go to next and last topic of our syllabus, that is nothing but what? Free expansion. what exactly the free expansion means. If you remember, already we learned the free expansion. So let's start with this free expansion. So this free expansion is a type of one of the type of adiabatic process. It is sometimes said to be adiabatic expansion. So there is no exchange of heat to the surrounding. Okay, so it is adiabatic expansion, and so that no work on system or by the system was done. And according to first law, here it is delta U equal to 0 and Q equal to W equal to 0. That because it is a free expansion. One of the best example for this, when we blow the balloon and we puncture the balloon or tire, it is seen that abruptly the air inside the balloon comes out without exchange of heat. It comes out. This is one of the best example for this. Free expansion is different from the thermodynamic processes. Why it is different? Because it is uncontrolled process. Once we leak the balloon, quickly, abruptly, very fast the air comes out. So it is uncontrolled process. And it is instantaneous change. The system is not a thermodynamic system. Not in thermodynamic system in the sense, not in thermodynamic equilibrium that they want to explain. The free expansion cannot be explained on the basis of PV diagram. Up till now, whatever the process we have seen, we have drawn the PV diagram. But for this, we can't draw the PV diagram because it is not a thermodynamic process, because it is not in thermodynamic equilibrium. So this is nothing but what? The free expansion, or we can say free expansion of the gas. In this fashion, we have completed this chapter. Might be there is some question in your mind that further there are heat engines and Carnot cycles, heat engine, heat pumps, that things are there. But this year, it comes the refrigerator, that part comes in reduced syllabus. So that this topic get eliminated. For the 4 pages are remaining. 4, not 4, it's more than 4. 4. 5 pages are remaining. 5 into 2, 10 pages are remaining, but this topic get excluded from the syllabus because it is reduced syllabus because of COVID-19. So that you have to prepare up till now. This chapter we have to prepare up till now, and in this fashion we have completed this chapter. I would like to remind you that if you remember, we have up till now completed a lot of chapters. How many chapters we have completed, that will revise. Rotational dynamics we have completed. If you remember, mechanical properties of fluid, that also we have completed. Kinetic theory of gases and radiation, that also we have finished. Thermodynamics, that also we have finished. Oscillation, that is also finished. Superposition of wave, that also finished. So total 6 chapter plus current electricity we have finished, if you remember, and semiconductor we have finished. 6 plus 2, 8 chapters are finished. Out of 16 chapters, 8 chapters are finished, means 50% syllabus of our board examination we have covered up till now. I hope that all of you have prepared this 8 chapter very well. If you have not prepared well, prepared it now, because remember, your examination would be carried out might be in March or April, but definitely there would be the exam. So 8 chapters we have prepared. You must prepare all these 8 chapters. And next period we'll start the next chapter, that is nothing but a wave optics. We start with the wave optics, then we go to electrostatics, then current electricity already we have finished, then remaining magnetic field of electric current, magnetic material, electromagnetic induction, AC circuits, dual nature of radiations, and atom molecule nuclei. This chapter we have to cover. So next period will start with the wave optics. So up to that, just that means I would like to tell you all the students, please prepare your all chapter I have finished. If it is possible to prepare the further chapter, is well and good for you, because according to every year session, every year up to October 31st, the syllabus must be covered by the students. Okay, must be, whole syllabus must be covered by the student up to 31st October. Now it is in November, end of November we are. So you must prepare very well. Only we have finished 8 chapter, but practically we have finished 8 chapter, but theoretically all of you must prepare your whole syllabus up to 31st October, and the revision must start from November. Then and only then you can score maximum marks in board examination. I hope all of you are preparing well. Those who have not started the study, you must start it quickly. Okay, so take care. Let's see you next week. Thank you.